So last class we were differentiating some functions using some rules. Okay, I gave you one formula, and that is derivative of x power n. This is nx power n minus 1. Okay, I did not prove this. I just showed that this makes sense for x square, but then I told that this was for any real valued n. Is it okay? So what is d by dx of d by dr of r cube? (3r square) using this formula. See, the thing is, x is just a variable. The name of the variable is not important. Even if I call it r, it still works. Okay, so we saw that in some problems. Like in some problems, the function was given as a function of a variable t. All right, the name of the variable doesn't matter. Okay, in fact, it need not even be an alphabet. You could just have a Mickey Mouse symbol or something. D Mickey Mouse cube divided by d Mickey Mouse is 3 Mickey Mouse square, because it's just a symbol. You understand? All right. Okay. So then we learned, how many rules did we learn? 5 rules in total. We learned a fifth one. Am I here to tell you? 5 we learned. What are those? There are constant rule. Mantras. Let's see the mantra. Constant rule. Leave constants alone. Take constants out. Sum rule. Sum of derivative is equal to derivative of sum. All right. After that, product rule. So if you have u into v derivative, that is derivative of first function into second function plus first function into derivative of second function. Last one, quotient rule. So that's 4, right? 4. Yeah, the difference rule is actually not a new rule. It just follows from some rule and constant. Okay. So quotient rule, that mantra we have to remember. Denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. Okay. So using this we solved problems which was the last. Given y is equal to 3x minus 2 into x plus 4. Okay. So I'll write the question completely. Find gradient of the above curve at 3,49. Okay. Now gradient is just another name for slope. Alright. And last class we saw that derivative will be equal to slope of the tangent. Right? Remember, I had drawn a tangent and told that if you zoom into it, the curve looks like the straight line, that tangent, and the slope of the curve and the slope of the tangent will match. Okay. And then the slope of the tangent is change in y by change in x. So slope of the curve will also be change in y by change in x. If you just look at it again, you will recall. Okay. If you still don't recall it, it's fine, because all we need to know is how to differentiate. Okay. I mean, it's good if you realize what it really means, but more important thing for us is to use it as a tool. Clear? Okay. Now, gradient you understand. Now, what is this at? First of all, where is the curve? Which curve are we talking about? I mean, it's a stupid question, but I want you to answer it. I didn't give you any curve, and I'm saying above curve. Huh? Very good. So this function, if you plot a graph of that function, y versus x, that will be a curve. And she identified that this is a quadratic equation. Okay. If you plot this, do you know how to plot quadratic expressions? Okay. So what will that quadratic expression look like? Can you just roughly sketch it? I mean, don't mark any points, just sketch it. Not slightly more accurate. All of you try to just sketch that curve. I'm saying sketch means you don't have to measure things. Understood? But it should be kind of accurate. In the polynomials chapter, you must have learned how to plot at least first degree and second degree polynomials. You see that this takes the value 0 when x is minus 4. If x is minus 4, what's the value of y? If x is minus 4, what's the value of y? 0. So when x is minus 4, y will be 0. So this is a point that lies on the curve. Okay. And when x is plus 2 by 3, what's going to happen? You get 2 minus 2, again y becomes 0. So when x is plus 2 by 3, again y becomes 0. So this is minus 4, this is plus 2 by 3. So these 2 points lie on that curve. And what does this curve look like? Do you know what a quadratic polynomial at least looks like? Something like this, a parabola. That's what I meant. You know that it's a parabola, right? That's all. So it's a parabola, it will be somewhat like this. Okay. Now 3, 49 is a point on this parabola. Check out. Put x equal to 3. What do you get? All of you just do not have to write. I mean, do you need to write? Just put x equal to 3 here and see what you get. (49), right? So do you see that 3, 49 must lie on this parabola because it's a point that satisfies this equation, right? So 3, 49 will be somewhere over here. Now let's look at the question. Find gradient of the above curve, that is a curve corresponding to this equation at 3, 49. What does that mean? Gradient is the slope of the curve, which means slope of the tangent, right? So if I draw a tangent to the curve, we have to find the slope of the tangent. That is what the question is telling you. Okay, but again, I do all this just to show you what the question is asking. The answer is purely algebraic. The solution is purely algebraic. You don't have to draw anything because we know that slope of the tangent is equal to the derivative at that point. Okay, are you used to the words derivative? Do you remember what it is? Okay, yeah. So all we have to do is differentiate this. We will get something here that contains x. Substitute the x value and you will get the gradient or the slope. They are the same thing. Her question is, that's the point. There are 2 ways you can do this, right? So she was asking, should I multiply this and then differentiate, or should I keep it as it is and differentiate using a rule? Which rule should I use? Something into something, product rule. We will do it both ways and see that the answers match. Understood? So first, let us expand the bracket. So derivative of y, d by dx of y, that is derivative of y, is basically derivative of, let us expand the bracket. You get a quadratic equation. Write it down, then differentiate. So I'll write it here. d by dx of x power n is n into x power n minus 1. X is the variable, okay. d by dx of constant into a function of x is constant into d by dx of function of x. d by dx of one function of x plus another function of x is d by dx of one function of x plus d by dx of the other function. Okay. d by dx of f of x into g of x is f into derivative of g. Please take this down, okay. These are the rules. Now, important thing is this d by dx is a symbol which is a shorthand for derivative of. Don't think that this is d divided by dx. Especially don't cancel out these two d's. Okay, it's just a symbol, right? Instead of always writing in English derivative of, it's going to take a lot time. So basically, this is a shorthand for it. Is that clear? Okay. Now I'll do that here. So pay attention. I'll solve some problems completely so that you see the pattern here. Okay. So first thing, expand this. constant can be written as x power 0. No. Yeah, 0. Derivative is 0. Okay. So you get 3x square plus 10x minus 8. Correct? Now we have to differentiate. We use those rules. First, using sum rule, you can separate each term out. That is rule number 3 that I have written here. See, line 3. This can be written as okay. Now, next which rule should I apply? 3 into x square, 10 into x. If it is x square only, I can differentiate. I can find the derivative. First rule I can use. But there is a constant in front of it. So I'll use the second rule to bring the constant out. So this can be written as yearly. For you it's new, right? Pay attention. So dy by dx is equal to clear, right? Okay. Now we use the first formula. X power 2, if I differentiate, I get 2 into x power 2 minus 1, which is 2x. X power 1, if I differentiate, use that rule and tell me what will you get. X power 1, if I differentiate, put n equal to 1. 1 into x power 1 minus 1. What is x power 0? Anything power 0 is 1. So it's just 1. So 10 into derivative of x is 1. Minus 8 into 1 can be written as x power 0. X power 0. So if you differentiate, use this rule, 0 comes here, 0 into anything is 0. So the final answer is 6x plus 10. Clear? Okay. Now we will do the same problem in a slightly different way, that is using product rule. Here I expanded the function. Let us try to solve it without expanding it. Okay. Right. Okay. So without expanding, we will use this rule. So differentiate first function. d by dx of 1 can be written as x power 0. d by dx of x power 0 using the formula is 0 into x power 0 minus 1. What is 0 into anything? 0. Now, if you were there in the last class and you have a sense of what the derivative means, derivative is change in y by change in x, right? So if you have just 1 is a constant. There is no variable at all, right? What is the change in a constant? No change, but how do you call that mathematically? No change is which number? 0. Okay, so change in a constant is 0, so derivative of 1 has to be 0. That's fine. Alright, so let us now go through the step by step. So 3x minus 2, if I differentiate. First I look at each term separately. Constants, take them out, right? So you just have to differentiate x. So 3 into derivative of x is 1. What is derivative of 2? 2 is a constant. Derivative of any constant is 0. So 3 into 1 minus 0 into x plus 4. Remember, second function we are leaving it untouched. Okay. First function we differentiate. So sorry, here first function we differentiate. Second function leave it untouched. Okay. Then next one, keep the first function untouched, differentiate the second function. What will this derivative of this be? 1 plus 0. 1. Understood, right? Derivative of x is 1. Derivative of 4 is 0. Okay? 1 plus 0. X plus 4 into what? X plus 4 into 3. Because this whole thing we found out is 3. And then plus 3x minus 2. 3x minus 2 into what? Derivative of that is 1. So what you get? 3x plus 3x, which is 6x. 4 3s are 12 minus 2, which is 10. Do you see that these two are the same? Everyone okay with this? Yeah. Doubt? If anyone has doubt, let me know. Okay. Now we are kind of not done. There is one more thing to be done. What is the question? Find the gradient of the above curve at 3,49. So where is this 3,49 did we put? Yeah. So what should we do? Plug it in here. Substitute. So final answer is 28. Put x equal to 3 here. So at 3,49, you get slope is equal to gradient is equal to 28. Let's be organized. First, tell me the derivative of the numerator. Just the numerator. Find that out. If you want, you can use paper and then tell me. 3. Okay. Derivative of the numerator. If you do it according to the rules of the previous problem that we did, you get 3. Derivative of denominator 4x. Okay. Now substitute in that formula. So which one should I ignore?
No. Oh wait, I've done something.
Yeah, till here it's fine. Okay.
Yeah.
Next step.
Till here. This is not.
No. Minus 6x square plus 36x. This step itself is wrong. I'll come. Do you want help? With that one? Okay, so d by dx of. No, try it yourself. Just make sure you get it as 3. After that, you can substitute in the formula and you will get the answer. Okay. So d by dx of f is what is f there? F is the numerator. Write it d by dx of 3x minus 9. Write it there somewhere. D by dx of 3x minus 9. No, you shouldn't write off. That off is the bracket. Minus 9. Now use the rule. Split it into 2 pieces and write d by dx of 3x minus d by dx of 9. That is the sum rule, the splitting rule. Good. 9. Now next, constants. Constants are like kids. You are not supposed to harm them. Okay, this derivative kills things. So you take it out of the derivative in order to not harm them. Okay. 3 into d by dx of x minus d by dx of 9. Okay. Now for both of these, we use the rule. First rule. Constant derivative is 0 and x derivative use that rule. Yeah. Yeah, I'll come. I just finished this. Yeah. 6x squared. Where is the next step? Here is the next step. Okay. Minus 6x squared plus 36x. So you took minus 6x.
I took 2x.
Okay. You took minus x common. 2x common minus 3x plus 18. divided by 2x into 2x cube, correct 2x minus 3 plus 18 by 2x cube. Yeah. Could you tell me the final expression? Where did you substitute? Here you substitute. Right? Wait, minus 3x. So now I will just use the rule. Just see if you can follow. Denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator whole square. Just follow it to see if you can follow the steps.
How do I substitute?
Yeah. Now the thing is, you are asked to find the derivative at the point where the slope, where the curve crosses the x-axis. So at the point where curve crosses the x-axis, what is the y-coordinate? So if you equate y equal to 0 there, can't you find for what x that happens? Huh? Not there, not there. See, the curve equation is that. The one at the top is the curve equation. That if it is 0, that means at that point the curve is hitting the x-axis. Fine. Next step is to substitute. You have to substitute some value for x. But x is not given to us. Instead, what is asked? The point where the curve intersects the x-axis. What happens to the y-coordinate when the curve intersects the x-axis? Y-coordinate is 0 on the x-axis, right? So we can plug in y equal to 0 at x-axis, y equal to 0. So you can substitute and find the value of x, that is 3x minus 9 by 2x square is equal to 0. For what value of x does this happen? Okay, so this happens when x is equal to 3, because numerator should be 0. 3x minus 9 is 0, tells you x is 3. Am I making sense? Right. So x equal to 3 substituted here, you get gradient is equal to minus 3 into 3 minus 6, which is minus 3, divided by 2 into minus 3 the whole cube, which is 27. So final answer will be minus 1 by 6. The final answer is minus 1 by 6. Mistake, I'm sorry. Plus 1 by 6. Thanks. Plus 1 by 6. Will be still here. Yeah. So after that, we have to substitute a value of x, because they didn't just ask us to find the gradient. They said find the gradient at some point. And what was the point they said? X-axis. So if I have some curve, okay, let's say this is your coordinate system. You have some curve and it cuts the x-axis at that point. What will be the y-coordinate of that point? If it's here, what is the y-coordinate? X comma 0 are the coordinates of it, right? So y-coordinate is 0. Now you know that curve satisfies this equation. So if you plug in y equal to 0, you can find what is the value of x for which y becomes 0. And then that x happens to be 3. Then you can substitute it. Yeah. Oh, 1 second. This is 0, not this. This is the derivative, okay. Alright. So I have committed a sin. Here, there is a sin that has been committed. What is that sin? I got equal to. Equal to what? So this is d by dx of y. Okay. So y has to be 0. Softly, man. If you are talking to him, he should hear it. I should not. You understand? Okay. So you are not supposed to put this equal to 0, not this. Sorry, you are supposed to put this equal to 0, not this. You can tell me why we differentiate. It is a sensitivity. Very good. The derivative in one quantity depends on another quantity. The derivative is a measure of sensitivity. How sensitive is that dependence? You understand? It can do more than that, but that's just a gist of it. Okay. By the way, you are asking what is the usefulness of it, right? What is velocity? No. Tell me what is velocity? Displacement by wrong. Rate of change of wrong. No, wrong. So I'll tell you, if someone, you are right now from a physics and math point of view, you're still kids only. Okay, that is why when I ask you what is velocity, you are giving me English answers, right? If physics and math could be done in English, if physics can be done in English, then why would anyone spend time learning math? Physics cannot be done in English, it has to be done in math. So actually, v is dx by dt, where x is position, t is time. This is how velocity is defined. You understand? If you ask me, sir, why is v dx by dt? What should I say? That's how it is defined, right? If I ask you, so what's your name? Aryan. If I ask what's your name, Aryan, and then I ask, how is your name Aryan? Your parents did not solve some equation to prove that your name is Aryan. You understand? That's how you were defined. Similarly, velocity is dx by dt by definition. Do you understand? Okay. What is current? You should be okay with giving wrong answers. You don't learn unless you are wrong. What is current? Q by T, charge per time, no rate of flow of charge. Actually, it is dq by dt. What is pressure? What is density? Okay, so you are now wondering, like, without knowing differentiation, we have been talking about density. Why is this guy suddenly putting this in our lives? Right? Next year you will understand what will happen if you write density as m by v and not dm by dv. How wrong you will be, you will understand. Okay, because right now you are surviving without knowing all this. You are like, I have solved all many problems without ever using dm by dv. That's because those problems were chosen so carefully and given to you, like nice problems were given to you where it works if you just put m by v. Okay. Why are they teaching you that? Because we are human beings. Right? So the thing is, see, imagine this. What is a circle? What is a circle? A collection of points that are equidistant from a given point, or locus of all points that are equidistant from a given point. If your younger brother or sister who is in UKG comes and tells you, asks you what is a circle, will you tell them Euclid's 3 axioms and then say, points are like this, and then say locus of all points equidistant from a given point is circle? Will you say that? No. You will do this. And this is a circle. Do you understand? So the point is, we are human beings and we can't give you the final thing right now. We give you simpler things. Develop on it. Okay, so that you understand. So most of the things you have learned are not completely accurate. but they are useful. They are not useless because you can build on it and make your knowledge better. Best example is when you were young, you were told the earth is round. Then you learned round is a bad word because bangles are round. The earth is not like a bangle, right? So then they said, you know what, it's a 3D shape, it's actually called a sphere, it's like a ball. But then later you learn that it's flattened at the poles, it's an oblate ellipsoid. It's not even a sphere. That shape is called oblate ellipsoid. It's like a sphere but squeezed at the two poles. Alright? So you add on to your knowledge. Now if you tell a kid the earth is an oblate or ellipsoid, if he's a really studious kid, okay, like second standard kid, you tell him, he will by heart it. And he will write the answer. And he will get marks in the exam. But does he know the shape of the earth? He knows it's an oblate ellipsoid, which is something. This is oblate ellipsoid, he will think. Okay. So basically, you accept things. Kids will also accept it. If you tell the kid it's an oblate ellipsoid, he will say yes. Okay, and he will tell his friends, did you know earth is an oblate ellipsoid? And the friends will be like, really? And they will all feel they have understood something. Okay, but really they don't know what the earth looks like. If you ask them to draw it, they'll have no clue. Do you understand? So that is why we start with stupid things. Not stupid, like it's not really stupid. Okay, it's very important. Basic things. We start with basic things and then we add features to it, add details to it. Is that clear? So this is the importance of calculus. Every single physical quantity that you know, 90% of them are defined in terms of d by d something. You understand? I could keep going. So many things. Alright? You learn Faraday's law, or you are going to learn it this year. Faraday's law. Faraday's law tells you E is equal to minus d phi by dt. They just give you phi by t, no? That's what it's actually d phi by dt. So if you do not know calculus, that's why I said something in the last class. You will be differentiating for the rest of your career. Okay. So I mean, I can give you proof, but you'll have to trust me on that. This is, I think, enough proof for now. 11th and 12th standard, you will need it. Is that clear? Okay. The gradient of the curve y is equal to ax plus b by x square at a point 1, 11 is 2. The gradient is given to you. The gradient of the curve y is equal to ax plus b by x square at the point 1, 11 is 2. Find a and b. Dhyan Shankar. Okay. Dhyan Shankar. Yeah. So differentiate ax plus b by x square. X square should be written as to differentiate. Minus 2 this is, what is this? This is fine. Okay, so derivative is a minus 2b x to the power minus 3. So that part we did. Now our job is to find a and b. A and b are two variables. How many equations do we need? 2. Okay. So what are the equations we can get? That is the derivative. What is this? dy by dt. This is fine. Okay. Yes, you can write it as x power minus 3. That's fine. Okay, now we got the derivative. And the question is to find a and b. So we need two equations. Okay, so can you tell me how to get at least one equation, anyone? So 2 is the gradient, right? 2 is given to be the gradient, right? So instead of dy by dx, substitute 2 and instead of, where is it 2? It is at x equal to 1. Instead of x, substitute 1. So a minus 2b. This is one equation. We need one more equation. Where can we get the other equation from? Someone over this side. A plus b is equal to what? 11. Good. So this point is also given to be on the curve. That means when x is equal to 1, y has to be 11. In other words, x equal to 1, y is equal to 11 should be a solution for this equation. You understand? See, if I give you a point that lies on a curve, won't that point satisfy the equation of that curve? Right? So it is given that gradient at this point, which means this point is a point on the curve. Otherwise, whose gradient are you finding? Right? So you are finding the gradient at this point, and this is a point on the curve. So it should satisfy the equation. So if you put x equal to 1 and y is equal to 11, it should satisfy that equation. Good. So put x equal to 1, y is equal to 11, you get a plus b equal to 11. Just keep solving these two. Yeah. Okay, what is your question?
11 plus 11 plus 8 is
So that 1 comma 11, that's given.
yeah,
That's a point on the curve.
yeah.
That means when x equal to 1, y should be 11 for that equation. See, when you draw that curve and that equation, what is the connection between those two? And I have drawn a random curve, but what I am drawing is I am drawing the set of all points that satisfy that equation. Okay, so put y is equal to mx plus c. Does that remind you? What is that? No, y equal to mx plus c is the general equation for a straight line. Okay. So when I say equation for a straight line, what that means is, if you have a coordinate system,
I hope that's correct. Because I'm not talking about it.
if you have a coordinate system and there is a straight line like this, you see that all these points will have some coordinates, right? So these coordinates are related to each other by an equation. That is of the form y is equal to some mx plus c. So when you say equation of a line, what you mean is equation that the points on the line satisfy. So similarly, this 1 comma 11 is on the curve, is a point on the curve. Because they said, so there is some curve, some random thing I have drawn there, right? So that point 1 comma 11 is on the curve. How do we know that? Because they said gradient of the curve at that point is 2. If that point is not even on the curve, it's like they said, Mount Everest is very steep in America. Would that make sense? Because America is not a mountain. Mount Everest has nothing to do with America. So if they're saying gradient is 2 at 1 comma 11, that means 1 comma 11 should lie somewhere on that curve. Otherwise, what gradient are you talking about? Understood? Okay. So 1 comma 11 is a point on the curve. That means 1 comma 11 should satisfy the equation of the curve. The equation of the curve is y is equal to ax plus byx. Okay, that is what this means. Geometrically, 1 comma 11 is on the curve. Algebraically, 1 comma 11 should satisfy the equation of the curve. So now let's put x is equal to 1 and y is equal to 11 here. So put y is equal to 11, x equal to 1. You get 11 is equal to
Just substitute.
substitute.
And then you need to find it.
Yeah.
2x plus
All of them done. 4x square plus 4x plus 9, 8x plus I'll just do these four because many of you are doing it, but others might be lost. So I'll just do it here. That's all it takes. What did I do? I just differentiated. X square by root x is x power 3 by 2. X by root x is x power 1 by 2. Now you use the first rule. Did you use quotient rule? I'll do it by quotient rule method also. This is not by quotient rule I did. Both of these I did not use quotient rule. All I did is I divided x square by x is x. And this is 5 by x. Understood? X square by root x is what? X square divided by x to the power 1 by 2. This is fine, right? From here when you differentiate it. Yeah, see, 3 is a constant, take it out. Differentiate x power 3 by 2 using that formula. Okay, that formula will give you 3 by 2 x power 3 by 2 minus 1, which is 3 by 2 x power 1 by 2. Okay, plus 1 by 2 x power 1 by 2 minus 1 x power minus 1 by 2. Yeah. Okay. Now, derivative of x square plus 5, tell me. Yeah, fourth one also I'll do. Fourth one I'll just do quickly using the quotient rule and then we are done. Okay. So denominator, so here it is 3x square plus. Yeah. Yeah, let's do it directly. Okay, maybe. find derivative of root x is, use the formula, you get 1 by 2 x power minus 3 by 2. Sorry, 1 by 2 x power minus 1 by 2. Okay, so this is the answer. Now you get, let's expand this. So 1 by x I'll take out, 6x power 3 by 2 minus 3 by 2 x power 3 by 2 minus 1 by 2 x power 1 by 2. Just look at the powers, keep track of the powers. Okay, x power 1 plus 1 by 2, 3 by 2, x power 1 by 2, 3x power 3 by 2, x power 1 by 2. Huh? It's okay, wait for some time. Otherwise, it will be, if some people go, then it will be disturbance for others. 1 minute. Divided by x. Okay. Okay, now 6 minus 3 by 2 is 6 minus 3 by 2 is how much? 9 by 2. 9 by 2 x power 3 by 2 plus 1 by 2 x power 1 by 2 into 1 by x. Yeah, so now if you divide by x, that gives you 9 by 2 x power 1 by 2 plus 1 by 2 x power minus 1 by 2.